The National Electrical Code does not prohibit the use of NM cable in buildings over 2 stories. The 1975 NEC allowed NM cable to be used in buildings up to 4 stories in height, and this requirement has not changed since then. However, some local building codes may restrict the use of NM cable in certain types of buildings, often due to fire safety concerns. Given that an electrical system is over 50 years old, a thorough assessment is essential to ensure its condition and compliance with current NEC and local building code requirements. This assessment should include several key steps. Firstly, inspect all NM cables for any signs of damage, age-related deterioration, and ensure they are properly installed according to code. Secondly, verify that the wire gauge sizes are adequate for the intended loads and that the circuit protection is appropriate for each circuit. Thirdly, carefully evaluate the grounding system and bonding to ensure it meets current safety standards and is functioning correctly. Based on the findings of this comprehensive assessment, a decision should be made regarding whether to repair or replace the existing wiring. If the wiring is found to be severely compromised, exhibiting widespread damage or deterioration, or if it does not meet current electrical codes, a complete replacement is highly recommended to ensure safety and compliance. If the wiring is generally in good condition and largely meets code requirements, it may be possible to repair individual circuits as they fail. However, this approach necessitates a comprehensive maintenance plan to continuously monitor the system and proactively address any potential issues that may arise. There are also special considerations to keep in mind. Verify that the 480 volts electrical supply for any chiller and associated equipment is properly installed, grounded, and protected to prevent electrical hazards and ensure efficient operation. Investigate the reason for the absence of 277 volts lighting. High voltage lighting options can offer energy efficiency benefits, potentially reducing energy consumption and cost for the facility. It is advisable to consult with a licensed electrician and local building authority to conduct a thorough assessment of the existing electrical system. These professionals can provide expert guidance on the best course of action for repair or replacement, ensuring compliance with all applicable codes and regulations. The decision to repair or replace electrical wiring in a building, especially one as critical as a nursing home, requires careful consideration of several factors. These factors include the age and condition of the existing wiring, its compliance with current electrical codes, and the potential risks associated with both repair and replacement options. Let's delve deeper into each of these aspects. The age of the wiring is a significant factor. Wiring installed in 1967 is now over 50 years old. Over time, wiring insulation can deteriorate, becoming brittle and cracked. This deterioration can lead to short circuits, ground faults, and increased fire risk. The type of wiring used, in this case NM cable, also plays a role. While NM cable is permitted in certain building types and heights according to the NEC, its condition after decades of service needs careful evaluation. A thorough inspection should assess the extent of any visible damage, such as cuts, abrasions, or signs of overheating. Additionally, the presence of any modifications or repairs performed over the years should be documented and inspected for code compliance. The most current edition of the NEC should be referenced to ensure that the existing wiring meets minimum safety standards. This includes evaluating the adequacy of wire gauge sizes for the connected loads, proper overcurrent protection, and correct grounding and bonding techniques. Any deviations from current code requirements should be carefully noted and addressed in the repair or replacement plan. The decision to repair or replace should also consider the potential risks associated with each option. Repairing individual circuits as they fail might seem like a cost-effective solution in the short term, but it can be disruptive to the facility's operations and may not address underlying issues with the overall electrical system. Partial repairs can also lead to a patchwork of wiring that is difficult to maintain and troubleshoot in the future. A complete replacement of the wiring is a more comprehensive solution that offers several advantages. It allows for the installation of new code-compliant wiring that meets current safety standards. It also provides an opportunity to upgrade the electrical system to meet the facility's current and future needs, such as increased power capacity or energy-efficient lighting. However, a complete replacement is a significant undertaking that requires careful planning and coordination to minimize disruption to the facility's operations. It is essential to develop a detailed scope of work, obtain necessary permits, and engage qualified electrical contractors with experience in similar projects. Consider the potential for hazardous materials such as asbestos in older buildings. If asbestos-containing materials are present, they must be properly handled and disposed of according to environmental regulations. The lack of 277 volts lighting in the nursing home is another issue to investigate. While it is not necessarily a code violation, 277 volts lighting is commonly used in commercial buildings because it is more energy efficient than 120 volts lighting. Installing 277 volts lighting could result in significant energy savings over time. In addition to the above considerations, it is essential to consult with the local building authority to determine any specific requirements or restrictions that may apply to electrical work in nursing homes. Some jurisdictions may have stricter regulations than the NEC, particularly regarding fire safety and patient safety. Ultimately, the decision to repair or replace the electrical wiring in the nursing home should be based on a comprehensive assessment of the wiring's condition, its compliance with current codes, and the potential risks and benefits of each option. Consulting with qualified professionals and obtaining all necessary permits are essential steps to ensure a safe and code-compliant electrical system. Remember, electrical safety is paramount in a healthcare facility, and any decision should prioritize the well-being of the residents and staff. Now let's consider the implications of using whatever was in the shop at the time for electrical repairs. This practice can create a dangerous and non-compliant electrical system. Mixing different gauges of wire, using incorrect overcurrent protection, and employing improper wiring methods can lead to overheating, short circuits, and fires. A properly designed electrical system relies on having appropriately sized conductors for the anticipated load, protected by circuit breakers or fuses of the correct amperage. Using undersized wire can cause it to overheat, potentially melting the insulation and causing a fire. Overcurrent protection devices are designed to trip and interrupt the circuit when the current exceeds the wire's ampacity, preventing damage. Using oversized breakers or fuses defeats this safety mechanism and increases the risk of fire. Improper wiring methods, such as using the wrong type of connectors or failing to properly secure the wiring, can also create hazards. Loose connections can cause arcing and overheating, while improperly secured wiring can be easily damaged. It is crucial to standardize the electrical system by removing any non-compliant wiring and replacing it with materials that meet current code requirements. This will improve the safety and reliability of the system, making it easier to maintain and troubleshoot in the future. The presence of unused 208 volts receptacles on each floor also warrants attention. If these receptacles are no longer needed, they should be disconnected and removed to prevent accidental use or tampering. The wiring for these receptacles should be properly terminated and insulated to eliminate any potential hazard. Disconnecting unused circuits not only enhances safety but also reduces energy consumption by eliminating phantom loads. Every electrical component consumes a small amount of power even when it is not actively being used. De-energizing unused circuits can contribute to energy savings and reduce the facility's overall operating costs. Regular electrical inspections are vital for identifying potential problems before they escalate into major hazards. These inspections should be conducted by a qualified electrician who can thoroughly assess the condition of the wiring, overcurrent protection devices, grounding system, and other electrical components. The electrician should provide a written report outlining any deficiencies and recommendations for corrective action. Addressing these deficiencies promptly can prevent electrical failures, reduce the risk of fire, and ensure the safety of the building's occupants. Consider implementing a preventative maintenance program for the electrical system. This program should include regular cleaning of electrical panels, tightening of connections, and testing of overcurrent protection devices. A well-maintained electrical system is more reliable and less prone to failures. A preventative maintenance program can also extend the lifespan of electrical equipment, reducing the need for costly replacement. When planning any electrical work, it is essential to obtain the necessary permits from the local building authority. Permits ensure that the work is performed by qualified individuals and that it complies with all applicable codes and regulations. The permit process typically involves submitting plans for review and undergoing inspections to verify compliance. Working without permits can result in fines and penalties, as well as potential safety hazards. Before undertaking any electrical work, always de-energize the circuit at the breaker panel. Use a voltage tester to verify that the circuit is de-energized before touching any wires. Lockout and tag-out procedures should be followed to prevent accidental re-energization of the circuit while work is in progress. Electricity can be deadly, and it is essential to take all necessary precautions to protect yourself from shock hazards. When working on electrical equipment, wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Avoid working in damp or wet conditions, as water can increase the risk of electric shock. Be aware of your surroundings and take precautions to prevent accidental contact with energized equipment. Finally, remember that electrical codes and regulations are constantly evolving. It is essential to stay up to date on the latest requirements to ensure that all electrical work is performed safely and in compliance with applicable standards. Attending continuing education courses and participating in industry training programs can help you stay informed about changes in the electrical industry.